In the beginning, there were machines of logic and ambition. Mechanized thought, born from war and wonder, gave rise to a new paradigm: computational intelligence. From Turing's abstractions to the electromechanical behemoths of the 1940s, we entered an era where logic became tangible. This is the chronicle of how electrons gave way to photons, and how vacuum-sealed ambition became a quantum reality. In the 1940s, vacuum tubes were the engines of computation. ENIAC, weighing over 27 tons, consumed 150 kilowatts of power to execute basic instructions. It marked the beginning of digital binary processing, but its limitations, thermal stress, fragility, and short lifespans, foreshadowed a need for evolution. This was the genesis of binary intelligence. In 1947, the invention of the transistor by Bardeen, Brattain, and Shockley changed everything. This solid-state switch, magnitude smaller and vastly more efficient than vacuum tubes, launched the semiconductor era. Transistors not only miniaturized logic, but made it portable, scalable, and reliable. A new trajectory had begun. With integrated circuits, logic circuits became compact ecosystems. The 1971 Intel 4004 packed over 2,000 transistors into a chip smaller than a fingernail. As transistor density doubled every 2 years, Moore's law guided an exponential climb. Computers escaped the confines of labs and entered the hands of humanity, unleashing personal, networked, and intelligent machines. The 1980s ignited the democratization of computation. From Steve Wozniak's wooden-cased Apple I to IBM's business workstations, personal computing became a cultural revolution. In parallel, supercomputers like Cray 1 and Blue Gene redefined science, simulating climate, folding proteins, and predicting particle physics. Yet, even these giants were still bound by classical constraints. Classical computation neared its thermodynamic limits. Enter quantum theory. Paul Benioff modeled quantum Turing machines. Richard Feynman challenged classical simulations of quantum systems. David Deutsch formalized the universal quantum computer. Peter Shor shattered RSA encryption theory. The seeds of the quantum revolution were sown, where bits could be 0 and 1, and algorithms could operate in multidimensional superposition. Now we enter the light age. Unlike electrons, photons do not scatter, resist, or heat. They carry qubits at light speed with minimal noise. Photonic quantum processors, crafted with silicon, gallium arsenide, and lithium niobate, guide light through entangled logic. With breakthroughs from PsiQuantum, Xanadu, and the Imperium Project, we are witnessing the emergence of scalable, room-temperature quantum systems. From vacuum valves to quantum vectors, from punched cards to photonic coherence, computation has evolved into a new language of nature. In photons, we do not merely find speed. We find structure, stability, and symmetry. The age of light is not approaching. It is here, and through it, we shall compute the cosmos. We hope to see you in the following video.